Hello, everyone. Welcome back to the good stuff we've been doing. In the previous videos, we discussed about the theory of distribution and how we can expand brackets in general. In this video, we will apply our theory to solving some problems. So let's see. Suppose we want to expand, say, a plus b squared. Now, by our work on the theory of indices, this is same thing as a plus b multiplying a plus b. Now, on the theory of distribution we discussed so far, what do we do with this? First of all, we see that the product we form, it will be as follows. A will multiply, we get the partial product, like we get a b c, a b then a b. We will form the partial products. In the partial product we're going to form, we're not going to form it directly. We're going to see that the only distinct terms that appear here, first of all, we'll have a square appearing, and then we also have b squared appearing, because we take a from here and a from here, and then b from here and b from here. Then we'll get something like ab appearing, because a is taken from here and b is taken from here as well, appearing. But then we are supposed to have 2 times 2, which is 4 terms here, but we're having 3. So it seems that at least one of them must repeat. A square cannot repeat, because we form a square by taking one of a here and one of a here, which can be done in only one way, since there is no 2 a's here. For the same reason, b square cannot repeat. But then again, we notice that ab may actually repeat. We may take a here and then b here, or we may take b here and then a here. So you see that ab may actually repeat. So what we will have in the general case will be a square plus 2ab plus b squared. I prefer to write it in this form. Now, for the next example, suppose then we have a minus a plus b multiplying a minus b. Of course, the terms that will be different here are the a squared and the negative b squared, because one of the b's has a negative sign. But then here we will see that the terms like ab that appears, we have a negative ab as well. So ab will appear, but then a negative ab will appear. So they will destroy each other. So what we will have in the final case should be a squared minus b squared, which is true. Now, suppose that we have to form no, it's all about that. So suppose that this is a squared, sorry, this is a squared minus b squared. I'm supposed to take this part off. So yeah, so now assume that in the more general case, let's say we have to worry about a plus b all to the third power. So how many distinct products can we form from a and b, where we take 3, multiplying, taking 3 at a time? Like we get a b, but we take 3 from here. So in this case now, we may have a cubed, because the reason is that if you expand this thing here, just like what we did before in our previous expansion, we had a plus b, we have c plus d, and we had e plus f. We had 3 terms each, either a, c, and e, plus b, c, and d, or something like that. No, b, c, and f. So like each, we had 3 terms for each, just like I explained. So we will have a, b, c. We have a, b, c. We still have a, b, c, and then we still have a, b, c. But just like here, we had a, b, and then you have c, d, and then you have e, f. So what we have, like, one term is going to come out here, one term is going to come out here, one term is going to come out here. So in the what we should have in general is that we're going to get a cubed, not equals. So we're going to get a cubed. Then we may take two a's from here to get a square, and then we'll get a b. Or we may take a single a and then two b's from here to get a b squared. And then we may take each of the b's and multiply out to get b to the third power. So this is the distinct product that will appear. Like these terms, there's no anything that will appear has to be a multiple of this product. So we can only get a cubed, a squared b, a b squared, or b cubed. But how many they appear, we are not sure of. Now let's see. If we take this term a plus b or to the third power, it is equals to a plus b multiplying a plus b, and then we multiply a plus b again. So we get a total of 2 times 2 times 2, which is 6 terms. But then when we expand this out, we see that we get 4 terms only. So see that some of them must have repeated. Let's see, we have a cubed. A squared b, how do we form a squared b? We can take 1a from this bracket and 1a from this bracket, and then we'll pick a b from the third bracket. Or we may take 1a from this bracket, 1a from this bracket, and pick a b from the third bracket. Or we may take 1a from here and 1a from here and pick a b from the third. So see that we actually have 3 ways we can form a squared b. So there are 3 ways we can form a squared b. So it must have repeated 3 times. What about this guy here? This ab square. No, ab square. Sorry, like I meant to say 2 times 2 times 2 is actually 8 times, not 8 times. So for example, ab square here, we'll be taking we'll take 1a here and 2 b's here. Or we'll take 1a and 1b and 2 b's here. Or we'll take 1a and 2 b's here. So there are 3 distinct ways we can form ab square. So we should have 3ab squared. Then b cubed will appear. So if you count this, we have 3 terms here. 3 terms here, 6 plus 1 plus 1, 8 terms, which it should be 8 terms in total. Yes, let's say if you even work out a plus b or to the 4th power, this will give you a plus b. I think it's time to. This will give you a plus b multiplying a plus b. They will multiply a plus b and then a plus b as well. Now let's find a distinct term that may appear. We should get something like a to the 4th power will appear. A cubed, not equal. A cubed b will appear, obviously. A squared b squared would appear. A b to the 3rd power will appear, and then b to the 4th power will appear. So we get 2, 4, 5 distinct terms that will appear when we form this product. The other ones that will appear will have to be a multiple of these terms here. Because in this case now, we can this a cube here, we take 3 a's here and 3 a's, 1 from 2, 3, and then 1 b here. So these are distinct products we can get. Now how many times do they appear? Let's see. Here we have a to the 4th power. First of all, the a cubed, to form a cubed, we have to take from this 4 brackets, we have to take 3 a's here and then 1 of the b here. Or we may take 3 a's here and then 1 of the b here. Or we may take, so we have for each, so we can, 1 of the b can be selected in any of the 4 brackets. So 1 of the b can be taken from any of the 4, and the a cube will be taken from the rest. So we have 4 distinct ways to form this. So we have 4 a cubed b. Now what we have next is that, what about a squared b squared? But to form a squared b squared, we take 1a here and then 1a here, and then we can take the remaining b and b here. So we see that here we have 2 ways we can do it. Like we take an a here and an a here, and take a b and a b here. So like so outside this, when we take an a out here, we remaining 2 brackets here. 2 brackets here for the b. So the b's have 2 choices. For the b parts have 2 choices. For each of the two choices make for a. Likewise, we can come here and take a here and a here, and we still have 2 choices for b. And likewise, we can come here and take a here and then a here, and then we still have 2 choices for b. So we have a total of 3 ways we can take a. But for each of the 3 places we can take a, we have 2 choices for b. So in this case, we have a total of 3 times 2 number of ways this number will appear. So this will give us 6a squared b squared. Then for the same reason again, we'll be having 4ab cubed, because for each of these products here, like we take b cube, b can be taken of any of these three, a was selected from the rest one, so we have 4 choices for a. Likewise, we have a b to the fourth power here. So what we should have is 2 times 2 times 2 times 2, which is 16, and we have a 16 tempo. This is 10 plus 4, 14 plus 1 and 1, which is 16 terms we have appearing here. So this is the way you can distribute products using words. One of the reasons I took this approach is because when we learn combination and permutation, or permutation and combination, I said it in reverse order, we will be needing this knowledge of distribution to find the general theory of binomial expansions. So like this a square b square, I know it may look a bit confusing at first, like a square b square, but the reason is actually clear. Here we take two terms here. A can be taken from here and here, and then we still have two choices for b, and then this a square can taken either here or here. Then we'll be having two choices for b. Then the a square can be taken either here or here. Then we'll then be having two choices for b. We'll have a total of 6 ways we can form this a square b square. So that is why we get this expansion here. Of course, we can actually expand a plus b plus c all to the third power, sorry, all to the second power square, like this. You can do this and get a square plus b square plus c square plus 2ab plus 2ac plus 2bc. The reason being that to form the distinct products are a square, b square, c square, ab, bc, and ac. These are the distinct terms that will appear. Anything that will appear again will be a multiple of them. Now, how many terms do we have? We have 1, 2, 3, 4, 5, 6. But we should have a total of 3 times 3, which is 9. Which is 9 terms. We should have a total of, because this is a plus b, like a plus b plus c, multiplying a plus b plus c. So we should have a total of 3 times 3, which is 9 terms appearing. Now, what we have next is that some of these terms might be repeated. These guys are not repeated, obviously, because if we have this to form a square, we'll take 1a here and 1a here. So maybe ab is repeated, because we can take ab here, or we'll take the ab here. No, sorry, no, we cannot take from one bracket. So we can take a and b here, or we can take b and b and a here. So we can form ab or ba. So each of them is done 2 times, and we have a square plus b square plus c square plus 2ab plus 2bc and plus 2ac. So that is general expansion. And using this approach, you can obviously expand a plus b plus c all to the third power. Please subscribe to the channel if you like my content. Thank you for watching. Have a nice day ahead.